Here is an example of what an error interval looks like. And now we're going to go into what an error interval is and explain the different parts of this. So an error interval shows you the range of possible values that a rounded number could have been before it was rounded. So let's have a look at this example in a little bit more detail so that we make sure that you understand all the different parts of this. So first of all, we're going to look at these signs to make sure that you know and understand what they are. So this sign here means that x is greater than or equal to 4.5. This one here means that x is less than 5.5. So if it has that extra line underneath, that means it could be equal to it. If it doesn't have it, it's either less than or greater than, but it can't be equal to that. Okay, so in terms of what this means in terms of the error interval. So this number here, the 4.5, is the minimum value that the number could have been before it was rounded. Sometimes this is also referred to as the lower bound, so you need to be familiar with both terms. So on this side, this number here, if you like, is the maximum, and that can also be referred to as the upper bound. So the upper bound or maximum is 5.5. X can't actually be that. It can be as close to that as is humanly possible, if you like, but it can't actually be 5.5, because what we know is that if it was 5.5, it would have rounded up to 6 instead of rounding to 5. So the rounded x value for this particular number would have been 5. The smallest it could have been would have been 4.5, and it could actually have been 4.5. It couldn't have been 5.5 because then we would have rounded it up, but it could have been 5.49 recurring forever. And that's how we use these lovely signs here to help us distinguish between those two aspects. So now we're going to do some examples. So in this first example, we're told that the length of the book is 22 centimetres measured to the nearest centimetre. So we're going to start by drawing ourselves a little diagram to help us figure out this error interval. So it's just a 3-prong, and it's actually going to look like a bit of a number line. That's what we're going to do. And we always put the number that we've been given in the middle. And then on the right hand side, we're going to go up 1, and I'm using 1 in inverted commas. In this case, it literally is 1 because our level of accuracy is to the nearest 1 centimetre. So we're going to go up 1 centimetre, and at the other end, we're going to go down 1 centimetre. So then we're now going to go to the halfway mark. So halfway between 21 and 22 is 21.5. Between 22 and 23 is 22.5. So this here is our minimum or lower bound, often abbreviated to LB. This value here is going to be our maximum or upper bound in our answer. So our error interval is going to look like this. We're going to have 21.5 less than or equal to the x x is less than 22.5. Now it's not always x in the middle, sometimes they use different letters. Here they could have used an L for length, for example, in the middle. Let's have a look at another example. So the weight of a book is 0.6 kilograms to one significant figure. So the first thing that we need to do is we need to set up our little three-prong affair, and we're going to have 0.6 sitting in the middle. So this time it's told us it's been rounded to one significant figure. So remember, with significant figures, zeros don't count. So 6 is that one significant figure. So in other words, this has been rounded to the nearest tenth. So this time we're going to go up 1/10 to 0.7 and down 1/10 to 0.5. So halfway is where we need to go. So halfway between 0.5 and 0.6 is 0.55, and over here we'll have 0.65, and so our error interval will be 0.55 less than or equal to, I'll call it W this time for weight, and that's less than 0.65. So the book at its lightest could have been 0.55 kilograms, because that would round up to 0.6 kilograms to one significant figure. The maximum it could have been would have been 0.64, with 9 going on forever, which for all practical purposes is really 0.65. Let's have a look at another example. So here, the amount spent on a new phone is £360 to the nearest £5. So we'll draw a little diagram again. Normal, we put the original number in the middle. Now this time it tells us it's been rounded to the nearest £5. So we're going to go up 5. So that will take us to 365, and we're going to go down 5 to 355. And then again, we just need to find those halfway marks. There's a difference of 5 between 355 and 360, and half of 5 is 2.5. So in between here we've got 5, 7, 5. And on this side we'd have 362.5. So our error interval will look like this, with 357.5 being less than or equal to x is less than 362.5. Now I've been a bit naughty there because this is money, so really I should have put that. Because it's money, we want those zeros on the end, because that's how we write money.